So when we compare these linear and exponential functions, there are three of them here. We first got to decide which are linear, which are exponential, and maybe one of them's nothing. Maybe it's neither. So the questions we have here is which function's linear, which function's exponential. Okay, so they want a linear, we want an exponential, and then after that it says which sequence or function, because the sequence really creates a function. Either way you could call it sequence or a function. Pattern of numbers, is the largest on the fourth term. Well, do you notice how we have the third term here? Do you see we have the third term? You have the 0, 1, 2, 3. So wouldn't the fourth term just be the next number in the patterns? So our three questions are, which is a linear, which is a exponential, and what would be the fourth term or the largest fourth term out of these? And these two have to have an explanation, explaining it. So let's think about how we would approach this problem. I want to approach this problem with first saying linear and exponential, saying which one's which. So a linear, do you understand, has a common difference, where exponential has a common ratio. That's what you talk about in sequence. But when you talk about it, maybe it makes more sense to you. This has a slope, this has a percent rate of change. If I'm talking about linear, I'm looking for the slope. I'm looking for my common difference. If I'm talking about exponential, I'm looking for my common ratio or my percent rate of change. So for my explain why, well, what I'm looking for here is a percent rate of change or a common ratio. That's what we're looking for exponentials. That's my explanation why. Something of that premises. Well, for a linear, we're looking for an average rate of change or a slope, which is your average rate of change, or it's called your common difference. So for this one, for linear, we're looking for common difference or slope. For exponential, we're looking for percent rate of change, which is your common ratio. So let's look at these two. Now, some of you could just look at it and tell. All right. Let's look for the common difference, or let's look at the first one. Does this one have a common difference or a common ratio, a common multiplier or divider? Well, what you look is, okay, as I go down, what's happening? Can you see you're adding 5? Now, if you can't just see you're adding 5, could I take 10 and minus 5? And then 15 minus 10. Can you see there's a common adding of 5 going on? So if there's a common adding of 5, is it adding 5 every time? Are we adding 5 every single time? Yeah. So if I'm adding 5 every single time, is that called a common difference? So that means that the first equation is linear, so that would be f of x. And my reason why is it has a slope. Either you could say m equals 5, or you could say that d equals 5. That's my reason. Because my common difference is 5, or my slope is 5. I'm explaining it. Because it's a constant common difference through the whole thing. So I know the first one's linear. All right, so that was the linear. Let's check this next one. Do I have a common difference as I go down? Well, I added 4, then I added 5, then I added 6. Does that make sense? No, I added 4, 5, 6. There is a pattern, but is it the same over and over? No, it's constantly growing. So is this a common difference? No. Again, the reason is this is a plus 4, then it's a plus 5, then it's a plus 6. Doesn't make sense. Now, let's see if it has a common ratio. Is 16 divided by 12 the same as 12 divided by 16? Sorry, 21 divided by 16. The same as 27 divided by 21. I kind of said that might confuse you, but for common ratio, don't you take this term divided by that term? This term divided by that term? And what you'll notice is it doesn't work. Meaning, if I take 16 divided by 12, that number is not the same as 21 divided by 16. that is not the same as 27 divided by 21. And I'll show you real quick how I did that. All right, what I'm going to do here is I'm quickly going to see that for the second one, 16 divided by 12 is 8 thirds. No, that's not. When you divide that, that's 4 thirds. But then when I go 21 divided by 16, that doesn't even reduce. If you did that on a calculator, what would you get? So when you divide this, you get 1.31. When you divide this one, you get 1.33. Those are different pieces. So this one and this one are different. It's very close, but is it the same number repeatedly? No. So I don't have to check the next one because it's not the same ratio. So number G is neither arithmetic nor geometric. It's neither adding the same thing, subtracting the same thing, or multiplying or dividing the same thing. So this one is neither pattern. Last one, sorry. Let's check if this one's exponential. Can you see a pattern here? Can you see right off you're not adding the same thing? Add 1, add 2, add 4. Do you see how it's constantly adding a different number? So let's try dividing. What's 2 divided by 1? Well, isn't that 2? Okay, what do I get here? What's 4 divided by 2? Oh, 2. What's 8 divided by 4? 2. Do you see how I'm multiplying by 2 repeatedly? See, that's the same pattern? I'm multiplying by 2 here. Oh, so guess what? This one, h of x, is your exponential. Why? Because your common ratio is 2. Or you could say your percent rate of change is 100%. Because isn't that 100% more than 1? Now, you don't have to put 100%. That's a 100% growth. Or you could think of your common ratio as 2. It's either way you can understand it. But you have to choose which one's arithmetic, which one's geometric. One of them's probably going to be neither. And then you got to explain it using either common ratios, common differences, or things like that. Now for the last question, which sequence or function has the largest fourth term? Well, if we're adding 5 each time, what's the next term going to be? Well, wouldn't this next one be 25? All right, this one, I do see a pattern, 4, 5, 6. I'm going to ignore that one because it's not arithmetic or geometric, but you do see a pattern. You probably could figure out the next number, but it's neither arithmetic nor geometric, or meaning linear or exponential. So it's neither one of those types, so I am going to exclude this one. So I'm going to just kind of cross that one out because it's neither linear nor exponential, even though you can see a pattern. Last one is if I'm multiplying by 2, what's the next number going to be? What's 8 times 2? 16. So which one is bigger for the fourth term? Well, you can see it's f of x, because f of 4 equals 25, and h of 4 equals 16. It doesn't ask for a reason, but that would be why. Because the fourth term on f is 25, the fourth term on h is 16. And g doesn't have either of the patterns we're looking for, even though it does have a pattern, just not the type we're looking at. Exponential are called geometric. Linear are called arithmetic. Next question. John has $20 and makes $30 every month. Ken has $2 and makes 60% more every month. Can you tell by looking at this who's exponential and who's linear? I hope so. Can you tell that John, let's make an equation for him. Let's call him f of x. Is John linear or exponential? Is he a percent or a slope? You see it's a slope? Which of those numbers is his slope? Is his slope 20 or 30? Which is the changing one? Or let's say, which one did he begin with, 20 or 30? 20. He began with 20, so isn't this his slope? And if you think back to that, wouldn't that be 30x plus 20 as his equation? Just think about that. If he started with 20 and he's gaining 30, wouldn't that be a linear line? your common difference, your zero term. Your b, your slope. Okay, that helps. Change the equation. Let's do kin now. Kin. We'll call him g of x. Kin, can you tell, has a percent. So he's exponential. Now, isn't 2 what he started with? So for exponential, can I start with 2? And are you going to do an x power? Now be careful. What goes in the parenthesis? Not 60%. Is he growing or shrinking by 60%? If he makes, he's going bigger. So 60% is how many cents? 60 cents. So I have 1 plus 0.6 or minus. Isn't it be plus? Won't that be Kin's equation? Now, did I have to make equations? No. Could I have made a table, like these problems? Could I have simply made a table and looked at the table and worked down the table until I kind of figured it out? Totally. Could you made a graph? Yeah. Okay. Now, now that we have the equations, exponential, okay, exponential, linear, can we answer these questions? Hopefully so. So, the question, who will have more 5 months from now? And we'll explain how much you'll have. And who will have more in 2 years? Now realize, sorry, I said it wrong. 3 years is how many months? 36 months. So you might want to write that down, because a lot of you have missed that. Oh, 36. Oh, okay. So 5 months is not very long. So because 5 months is not very long and 36 is a long time, don't exponentials tend to have more in the long haul? But in the short term, do linear tend to do better? Linear sometimes do better in the short time. Now, not always. Do we still want to plug in numbers? My opinion is, in 5 months, John's probably going to have more. In 36 months, very likely Ken will have more. But can we check? Let's check. So I want to, on this one, I'm finding f of 5 and g of 5. So f of 5, I'm going to put 5 into the function. And this one, I'm also going to put 5 into the function. And I want to see who is bigger. Now we're thinking that John's going to be bigger. Let's see. So when we do this math, 30 times 5 is 150, plus 20 is $170. All right? Now, you can't do kin without a calculator, but if you plug it in, you'll get $20.97. So hopefully you can tell, pretty obviously, kin is my answer. Sorry, no, I said it wrong. John has more. And how much does he have? Here's the prices. John has, oh, I should put it, John has $170. I should probably write that in there. Okay, because I asked for it. So John has $170. Can we check just to make sure? So let's now look at this one. 3 years, 36. So let's see who will be bigger at 36. So f of 36 will be 30 times 36 plus 20. And g of 36 is going to be 2 times 1.6 to the 36th power. And let's find those answers to see. Now, we talked about it. Didn't we think Ken is probably going to, because he's exponential? We'll see if it actually pans out, but it should probably make him bigger. All right, so what do we get for this guy when we multiply it through? We get $1,100. You might say, that's pretty good. All right, yeah, that's pretty good. Wait till you see Ken. Ken becomes 44605, 015, and let me see it. 1, 2, 3, 4, 5. Oops, I did. Nope, put the commas in the wrong spot. Oops, wrong. Okay, let me get that again. This thing's messing up. And then this one is going to be, it has 7 decimal places. That's what makes it hard. 1, 2, 3, 4, 5, 6, 7. So, who has more money? 44 million or 1,100? Ken has quite a bit more. Yeah, I don't know where Ken gets his money from, but hey, in 3 years he has 44 million bucks. Something's really weird here. So who has more? Ken. And that boy has a lot of money. $44,601,500. Yes. Good job, Ken. So for this one, you're plugging in 36. For this, you're plugging in 5. But you first must make the two equations. You must understand the difference between linear and exponential. Right here, you have the same idea, linear versus exponential, but it's in a table. Things could be graphs. I could give it to you as graphs. I could give it to you in many different ways, and you have to compare two scenarios.